Hi, my name is Joseph Griffiths, and I'll be presenting today on the operational aspects of hyper-converged infrastructure. Thanks for joining me. So we'll go through the disclaimer here, get that through. Now we've done that, I like to talk about what hyper-converged infrastructure is. And I'm going to take a quick poll of the room. If you think that hyper-converged infrastructure is the combination of compute and storage together, raise your hand. Okay. How many people in the room also consider hyper-converged infrastructure the combination of network with those two aspects? More hands. Okay, that's what I'm going to be talking a little bit about. I'm going to be talking about operationalizing both storage and networking. Because commonly we talk about networking, but I believe hyper-converged infrastructure is the combination of all three together. So our traditional model is shown on the left here. It just talks about our three tiers. We've got storage, networking, and compute, and we shove them all together. Why are we doing this? Well, the big driver to the business has to be the total cost of ownership. But for me, it has to be also the win around operationalization. It has to be cheaper for us to operate, and it has to have scalability built in. So that really comes down to simplified management. So that's why the three have to be together, is because otherwise you're missing a big component that needs a bunch of operationalization. Oh, yep, hold on. Oh, you go the wrong way. That's bad for me. Sorry about that. Okay, so I want to talk a little bit about the difference as I think about it. And anyone who wants the slide deck, come see me afterwards. I'll get you a copy of it. I have no problem sharing it. So when we really think about hyper-converged infrastructure, we need to have hyper-scalability. We need to be able to linearly grow, not just bulk grow by purchasing large things, but we need to linearly grow. And as we linearly grow, we need to have the same simplified management across the board. It needs to improve our agility because they're integrated. At least they should be integrated. So the agility should be improved as part of that process. And it should drive those operational efficiencies I talked about. Hopefully, if they're all integrated the way we've talked about, they're going to simplify our operations, and they're going to simplify our support, and they're going to increase our availability and performance, because now we can really deal with everything holistically. That should improve our troubleshooting as well, because now we have one element that's going to be driving all of those things. Okay, so I promised we'd be talking about operationalization, because the biggest challenge I see across the board is not, can we buy this? There are several companies that will sell this to you, but it's how do you take what you've traditionally done in networking and in storage and operationalize it in a hyper-converged world. So I'm going to talk about three elements, not the only elements, but the three elements I'm going to talk about are operational scalability, performance and availability, and organizational structure to make this a win. So first of all is the scalability, as I mentioned. When we start to look at hyper-converged infrastructure, it changes the model we do. We're used to storage array purchases. Once every 3 years, you go, or every 2 years, you go to the business and you say, hey, I need X million dollars for a storage arrays. One storage administrator I talked to described that as the flak jacket exercise, because he needed a flak jacket before he went on stage to tell him how much money he needed. With hyper-converged, the storage concept, instead of being large bulk purchases every couple of years, moves to a linear model. But this does change, because now you're going to the business several times a year saying, hey, I need another node, or I need another increase on my licensing, or whatever it is. I need to increase my capability. So we start to get into purchases where we're making a lot less bets on what we may be using in the future and a lot closer to what the business is using right now. We just have to change the business methodology, so we have to get used to that. That is a scalability difference. We have to tell them that they should not expect to see us 3 years from now, but should expect to see us maybe 3 months from now. It makes a big difference in the way we do it. But we do get more predictable outcomes. We do get the scalability that goes. Now, this same scalability comes on the networking side if it's done right, right? We just need to increase the number of nodes because we need more capabilities or more ports because we've hit our maximum. We keep doing that. It becomes scalable in that model as well. So there's a couple scalability best practices that I recommend, and these are quite generic across it, right? So build for your current scale, but understand that you're going to purchase incrementally. Your capacity absolutely can grow as your business grows, and you do need to establish a capacity management process for the storage. You need to monitor it, you need to trend it, and you need to figure out where it's going to be so that you can tell people, hey, 2 months from now, we're going to buy more, or if you add this project this month, we're going to need to buy this much more, right? You need to be able to have that. That doesn't change from traditional storage management at all. We have a little bit less of an issue on networking, but you also need to monitor your networking to know how much capacity and bandwidth you're using and get visibility into that to understand how much more you need to increase the nodes to meet your network performance needs. So, really, at the end of the day, your capacity management game is very much the same as it is today in the 3-tier, but the lead times have to be shorter, right? More often you're going to be doing it. All right, so I promised I would talk next about organizational structures, right? When you get into hyperconverged, now suddenly inside the hypervisor I have compute, storage, and networking. What does my team need to look like? A lot of people ask this question. What's the best team? Well, the answer is you've got people who understand security. You have people who understand networking. You have people that understand storage. You have people that understand compute. And you have people that understand virtualization. The best team is all of them together, working together on a common goal set. That's the best team. And what happens is you need to rotate each of those 5 people through the role so that they all learn the role so everybody can take it over, because we're supposed to be making it operationally simpler. But to do that, we've got to have people get to know each other's skill set as we drive it forward. We really need to focus those teams on the same outcomes. And we need to compensate them on the same outcomes. We can't compensate the storage people by saving storage while compensating the virtualization people for managing or mean time to failure. We have to do the same compensation methodology for everyone in this team so they have the same shared goals. And when you start to do that and align your performance with the same incentivization, you take down the silos that have existed before, and you start to see really that operational simplicity. It also enhances the ability to do automation as an organization. So the next thing I said I would talk about is storage performance and availability, right? And I'll have network performance on the next slide as well, so breaking both of them out. So when you get into a hyper-converged world, your storage performance is based upon policies, right? You have a performance policy, you have availability policy. There's a combination of both that makes a holistic policy. You are able to assign that per VMDK or per virtual machine disk that allows you to get different performance for different ones. So if you want to do your SQL Server base disk as a different performance than your data disk, you can do that. That's a nice feature functionality, because traditionally, of course, it was based on the LUN, and then you had to move it onto a different LUN to get different availability and different performance benefits. So that's one of the big operational simplicities, is I just change the policy and everything changes about it. And it allows us to change it on the fly. If we talk a little bit about networking performance and availability, as we take a look at that, we scale by adding more network cards or more nodes. And I don't want to discount the fact that there's physical networking involved here, because if you hit the limit on your physical switch or your router, you're going to need to increase those as well, right? So that's still part of this capacity. So you really need to understand your total bandwidth. But if you're hitting the hard limit on your bandwidth, add more cards, add more nodes, right? The distributed firewall that a lot of these solutions offer allows you to better control what traffic is going to be on the wire. So you may actually see a net reduction, because a lot of the garbage traffic doesn't happen. It never gets onto the wire. So your switches may not have to increase because of that. And we start to get into intelligent routing systems that do suppression of multicast traffic and all kinds of broadcast traffic that happens on the network. So we see a great deal of efficiency that come in. And our performance can exceed our physical implementation by keeping the resources in close proximity, right? So at the end of the day, if you know these two things are going to talk to each other, affinity rules are a good idea, right? Let's keep them together. Let's not make it go out to the wire. There's a lot of things that we can do to maximize that if you have visibility into it as part of your operationalization. All right, so I talked about this before, but I want to hit it again because this is such an important topic for me, which is really, what is the ideal team? Because I just told you a bunch of best practices. And if I was to caveat them, I'd say, hey, capacity management, you got to get the business used to the fact that there's going to be more requests more often, but they're going to be a lot smaller. And I think any business can accept that, because you're not betting or depreciating assets for 2 years that you're not going to use. If you think about the performance, the answer there is, hey, we have policies that align with our needs from a business perspective, and we're going to assign them, and we can change them as we need. More availability, more performance, we can change them on the fly. That's a huge win. Think about the amount of less things you have to move around between LUNs when you can do that. And then we talk about the third thing, which is really the biggest problem. How do we get the people to work together that we really gain all of that operational simplicity, right? How do we build that ideal team? Told you about the cross-functional skill set. That was the first thing I mentioned before. They need to be self-sufficient. They need to be diverse. They need to be leaders within the organization. They need to be willing to take on this challenge and learn new things. They have to have the growth mindset. They can't close down their mindset to I am the VLAN person, or I am the storage person, or I am the virtualization person. They have to be willing to learn each other's jobs. And as you find the right people and slot them in and then compensate them fairly and the same, then you start to build a team who can really accelerate your adoption of hyper-converged infrastructure in your environment. And you will find that it brings huge operational benefits to the organization. So, thank you. I'm not sure if we do surveys, but I appreciate you being here, and thanks for your time today.